Hi, my name is Frewen and I'm a graduate student in physics and astronomy, and I study polluted white dwarfs and exoplanet systems. A polluted white dwarf is a white dwarf, which is the end product of most stars, that has metals in the atmosphere. Metals just means anything that's heavier than hydrogen or helium. So for me, I run simulations to try to figure out how those metals get onto the white dwarfs. What we think are that the planets are sort of tossing asteroids onto the white dwarf, or maybe throwing comets onto the white dwarf. As a star dies, it puffs up really big, and that's what's called a red giant. After it does that, it sort of blows away its whole atmosphere and is left with this hot, dense core, which is what we call a white dwarf. And the planets, if they're far enough away, aren't really going to be affected. They're just going to keep spinning around and around and around. So we think that when the sun dies, it's going to puff up really big and it's going to gobble up Mercury, Venus, probably even the Earth. But stuff like Jupiter and Saturn are just going to be fine. And so in our own solar system, we have a whole big asteroid belt that falls between Mars and Jupiter, and sort of what I'm doing is seeing what would happen to that asteroid belt as the star evolves, gets big, and then turns into a white dwarf. So what we found is that for a planet like Jupiter, which is very big and orbits in a really very circular orbit, it's not very good at tossing stuff onto the white dwarf. But if you make Jupiter smaller, or very eccentric, that means spinning in an oval as opposed to a nice circle, it's a lot better at tossing things onto the star, whether it's the sun or a white dwarf.